Okay, this next example is going to help you with problem sets 11 through 22 on page 314. So let's go ahead and find the Laplace transform of these piecewise functions. So the first thing we want to do is we want to rewrite our function g of t, and we want to rewrite it in the form. So we want to write it as a product of the unit step function, right, which is going to be, we know is it's going to be a translation because we have a translation here, and it's going to be u of t minus 1, right, because this is our a is equal to 1, and we want to multiply it by the other function, right? This just means we're shifting, we're going to turn on the switch at 1, right, but we also have, right, this guy right here, so I'm going to multiply it by our t minus 1 squared. Okay, now remember, this is the unit step function, and this function here is a translation, right, of it's a translation of 1 unit to the right of some familiar function, right, that we've worked in algebra. And hopefully you can see, right, I mean, if I ignore that -1, if we cover that -1, we really just get t squared within this function. So I want you to maybe be thinking of, there's really a t squared in there, and maybe I'll call that just f of t, right? And then t minus 1 squared is just that same function translated 1 unit to the right. Okay, so the reason I wanted to rewrite it in this form is because now we can use theorem 1 in your book, because we want to find the Laplace transform of this guy. So let me just go ahead and write it out. The Laplace transform of u of t minus 1 times t minus 1 squared. Okay, so that's what I want to find, and according to theorem 1, specifically 3a, equation 3a, this is equal to e to the negative as. Okay, e to the negative a, well, it's just 1, so negative 1s or negative s, times capital F of s. Okay, so again, this is our, right, that's our goal right there. That's what we want to find. Okay, so let's just work with the right-hand side. And the right-hand side, just shift this over. Okay, we still have e to the negative s, right? Definitely want to find a function of s. But what is capital F of s? Well, capital F of s is just the Laplace transform of f of t, right? We know that. Well, what's f of t? Well, f of t is, and this is where the cloud comes in, the f of t is t squared, and then we just keep going, and then here we're going to use our Laplace transform. So what's the Laplace transform of t squared? Well, n is 2, so that's just 2 factorial over s to the n plus 1, so that's s cubed, and that's just, well, 2 over s cubed. So then the Laplace transform of our g of t, right, our piecewise function is, well, we can just say 2e to the negative s all over s cubed. And again, if you wanted to sketch this function, you don't have to, but if you wanted to sketch it, which is actually not a bad idea, I actually would encourage you to sketch it. So here we're at 1, and let's see, the switch is turned off. Well, actually when t is strictly less than 1, so it keeps going, and it's not included, so we should have an open circle. And when t is, let's see, that's t squared shifted right over 1, that's just a piece of a parabola, so maybe just bring that up, right? This is not, again, this is just a sketch, right? There's your t minus 1 squared, and that is definitely included. So hopefully that makes sense for numbers, well, starting at 11.